Well, ladies and germs, we seem to have had a 3D printing emergency. Last night while I was running this gentleman along with all of my other equipment, we had a power outage. And I'm sure that had nothing to do with me, but the effect of this is that our 3D print has stopped halfway. And this is a problem, but I believe we can fix it. Since I am controlling the 3D printer with FIFO pipes in Linux, I should be able to check the logs of my print. I'll show you the script in a second to show you how I'm going to do this, but I should be able to find exactly which gcode command led to this state. So exactly the XYZ position of the extruder right now should be available in the logs. From there, I should be able to just move the Z axis up about 10 millimeters to give it some space. I will be able to heat up the hotbed and the extruder back to their operational temperatures. And then I should be able to, again using the logs, pick up right where I left off in this print. So I know a lot of printers offer resuming functionality, and here we are going to be experimenting to try and find the manual version of that. So we are going to jump over to some code and we're going to try and save this print.
So on the left, I have this script that I wrote to actually control the 3D printer, and on the right, I have the file that I am trying to actually print. And I want to talk to you about how these two files work so that we can understand how the print might be salvaged. Now, first of all, we need to understand how these devices are communicating. My Arch Linux desktop is connected to the Ender 3 by a USB port. So the Ender 3 has a micro USB, and I just plug that directly into my computer, and that will give me this Teletypewriter device that I can send commands to. Unfortunately, this is a little bit messy. So if I'm not careful, I could send a command while it's trying to execute a command, and the printer will miss it. And this leads to globs of filament being dispensed and all sorts of unpleasant things, and the print will not come out well. So we need to have something that essentially controls this line of communication. And that is done with what is called a FIFO pipe, or a pipe, first in, first out pipe. And this file type is special in that it only allows you to read and write solid amounts of data. And that's a rather vague explanation. If I write hello, then you must read hello, only hello, and all of hello next. And so what I write will be read in whole next. And that is what allows us to have a much cleaner line of communication here. We need to do a little bit of setup in order to get all of this working. So first thing I do is create a pipe, and then I start sending all of the output from the 3D printer into that pipe. So this is writing to the pipe. And it does this in the background so that we can continue on doing other things. In the main function, what we're going to do is essentially enter a loop that will iterate over every single line of this print job. This is about 551,000 lines of code. So it will iterate 551,000 times, one line at a time, sending each command to the machine. So what we can do is first we are going to look at the prefix, so the very first character. We can see there are some comments here in the G code that are prefaced by a semicolon. So really we want to only send things that are actual commands, which are prefaced by a G or an M. So if it is prefaced by a G or an M, then we are going to start actually sending the commands. First, I create a log statement that says we are writing to the device, and then we send the actual command to the device. Once we send it to the device, we need to wait for it to be ready for the next command. And we can tell that it's ready in a few ways. Actually, this is rather unfortunate. I should instead say that the device will respond in a few different possible ways. It could respond with just a plain OK, which is generally what we are looking for. It might respond with OK and then some extra data, or it might respond with nothing at all. So in one of these circumstances, we need to send the next line of code. So we are going to read from the pipe. So as it is in the background sending responses from the machine into the pipe, we can read them cleanly, one at a time from the pipe. So we'll just keep reading them one at a time and logging every single response. And then we are going to keep doing this until the first two characters are okay. Once it's okay, we can exit the loop and we can send the next command. And that is the whole thing. I do a little bit of cleanup here to kill the background process and remove the pipe. We should check to see if that pipe actually got removed. Since this exited in a power outage, that pipe is probably still there. Let's check actually, just for fun. So, no, actually, it seems like once I logged out, it got deleted, which is actually rather reasonable. So anyway, I digress. So that is basically how our script here works. Now let's talk about the G-code. The G-code is every single motion that our extruder needs to make in order to print this. So for example, here, if we look at line 44, we can see the command is G1, and that means that we are going to be moving the extruder, and the 1 means we're going to extrude, as opposed to a 0 where we don't extrude. We then give it the coordinates where we want it to go. So in this case, 86.871, 80.87, and then we are going to extrude this amount. Now we can give it X, Y, Z coordinates and then E to extrude. So in total we can give 4, but we only have to give, we only have to give one of these coordinates or extrusions. So this is the whole print. Now, what we want to do is find exactly where the 3D print stopped, and once we have where it stopped, we should be able to find in the actual print, the print file where we need to pick up again. We'll add a few commands to that so that we can move it up on the x-axis, get the hot end to the appropriate temperature, we'll move back down, and then we'll resume. So let's talk about how we're going to do that. I'm going to move to this next window here. Now on the left, we have the print log. This is the log that I created from the actual print job. So this is every command that I sent and every response from the machine. And there are a lot of lines in this. So what we can do is compare the log to the actual print. Now what we need to do is some filtering here. So we have a lot of reads. So here, these are commands that the 3D printer sent back to Arch Linux, and we're not interested in these. We want to find the command that we last sent. So we can actually jump to the very bottom, not of that file, but of this file. Ah, that's interesting. So apparently once we had the power outage, this happened. I don't know what this would mean. This is probably an escape character. I don't know for what. I will Google it. Okay, so looking on Google, I did not find anything, which is odd. But we can see here are the last commands that were successfully executed on the 3D printer. So we had this motion and we had this motion. So it responded okay to this one, but it seems we did not get an okay response to this one. So the question is going to be, where do we want to pick up? Probably with this exact command. So what we need to do is find out which line in this file has this command. And we're going to use some better tools here. So I'm going to, with tmux, cut that screen in half, and I'm going to use grep. Grep is going to allow us to filter out particular elements from a file. So I can use cat to print the file. So documents, objects, satellite, and I'm going to pipe that into grep. And grep is going to essentially search. It's a regular expression search engine for this file. And what I want to look for is this command. So this command down here is going to print the contents of the file. We're then going to pipe that contents into the command grep. And grep allows us to do regular expression searches on text. And in this case, we don't have a regular expression. We just have the literal text that we want. And we want it to print out the line number that this text appears on. So I'm going to add the -n to print that line number, and we're going to see that it is printed on a number of lines, which is unfortunate. This actually makes quite a bit of sense though. If we think about what's happening here, the 3D printer is going to move over the same XY coordinates quite a bit. And yeah, since it is doing this layer by layer, each layer it is going to hit these exact same XY coordinates. And since it only is telling us the XY coordinates and not the Z or anything else, this is going to actually be a little bit more difficult to find. But we do have a few others. So this command here, this G1 F3600, maybe that is a little bit more unique. So let's try the exact same command with that. Okay, so now we can see if it's in there, and we have a single match. So in theory, this single match should tell us exactly where our print stopped. So here I can type in the line number of 93904, and let's take a look. So our litmus test is going to be to check the adjacent lines. So 93904, that's it. X 121.438, 121.438, 155.987. That looks good. And the preceding one, 7200. Yeah, that looks good. Are we missing one here? No, we're not. Okay, excellent. So it seems that this right here was the last successfully executed command in that 3D print. So in theory, if we start the print job here, we should be able to resume printing where we left off. But we want to make this a little bit more clean. So I am going to essentially create a new file that's going to be the restore print. And I'm going to add some additional commands to the beginning to give us that nice startup sequence. So just as a quick reminder, we can use cat to print out the contents of satellite.gcode. And if we pipe this into grep, we can search for the string that we are interested in and then print the line number that it occurs on. In this case, we are getting line number 93,904. Next, we can print satellite.gcode again, this time piping it into word count with -l as our argument to get the total number of lines in this file. So there are 551,736 in there. So if we print out the end of the file, so starting at the very end, the last 457,832 lines from that exact file, we can then pipe that into recovery.gcode, and that will be the basis for our new print. So this will essentially be picking up where it left off. And here we have the recovery file. So actually it starts here on line 16. So this was the last execution that was logged in our print, so that's where we're going to pick up. We did not get an OK response from this, so I decided to go ahead and execute it again. Now, I actually added a bit to the beginning, and if I open up, so we can see I actually just copied these commands from the beginning. This is just setting things up. So first, I tell it to move up to Z50. This is just to give it some space so the extruder is not getting hot right on the filament that's already printed, thus ruining what's there. It then increases the temperature of the bed to 60 degrees Celsius and then the extruder to 215. And then once that is done, we set it to absolute extrusion mode. I don't actually know what absolute extrusion mode is, so if you do, please leave it in the comments below. But it was done in the original print and it's part of the setup that was here, so I decided to leave it in again. I then need to move back to the original position. Now, since I did not change anything after it stopped, I can just move it up to Z50, and I'll just move it back down to Z27.8. And that is exactly the Z position of where it left off. But how do we find where it left off on the Z position? So if we look at our actual log, we can see that the Z is absent from most of these commands, and that's going to make it pretty difficult to find. But again, we can use grep. So if we just cat that and pipe it into grep, then we can search for just Z. And this will print out all of the occurrences of the letter Z. And we can see that the very last one is Z 27.8. So very simply, we can determine what the current Z position is. So we have this new set of commands. Actually, this is the old one, but whoops, I did it again. So from that, we get this new file that should cleanly pick up where the print failed last time, and that is how we will resume a failed print. I'm not sure if it will work, so maybe not take this as a tutorial just yet. I will be back shortly with the results. So before I can actually begin printing again, I need to set up the Teletypewriter, that is the 3D printer, and it occurred to me that I haven't shown this yet. So I'll do it now. This is the command that sets everything up, and essentially the important part of this is setting the baud rate. And what that is the clock speed of the motherboard of the 3D printer. So my computer, Arch Linux, needs to know what the clock speed of the Teletypewriter is. That way it can cleanly interpret the signals that are coming from it. And this command, set Teletypewriter on dev tty usb1 to 115200. Couldn't quickly get that number out. But we are also going to give it the arguments raw and -echo. Now, I don't remember exactly what these do. Once again, leave it in the comments if you can inform me of that. But I remember that I need them, so there they are. So we're going to set up the Teletypewriter. Whoa, whoa, whoa. Aha, I forgot something. Silly me. Gotta give it the F, because this is a file. Dev tty usb1 is a file, of course. So you gotta give it the -F. Why not? So with our Teletypewriter setup, we can restart the print job. If you are interested in taking a closer look at the script that I wrote to do this, it is available on my GitHub. And with that, we are ready to go. This is basically how you're going to use it, but I am going to add an additional argument here. So I'm going to pipe the output of this into T. And T is going to take its input and send it to standard out, but I can also send it to a file. So we can do our recovery log. So this is going to allow us to continue to monitor the output in real time on the screen here, but it's also going to be saving it to a new file called recovery.log. That way, if the power goes out again, we can redo this process and just keep picking up where we left off until things actually finish. So here we go. And like that, it seems our print has successfully recovered. It seems to be having a little bit of trouble with the height. Maybe I didn't set it quite high enough. It seems to be dragging a little bit, but I am expecting that to kind of level out over the layers. So we'll see how this affects the final print quality. To be determined. So that actually did not work as I expected. This was not the last command that was executed by the 3D printer. So when I put it back in, this does not actually move to where I would expect. And either it is sending commands that are being stored in a queue, in which case the proper position is further back in the log, or there were some commands that were sent back and forth that were corrupted when the power went out, and that is represented by these here. And this could be any number of commands after this one. I don't really know. So, operating first with the hypothesis that it is further back in the log, I wrote these two scripts to help test this theory. So, this first script is going to start in the gcode file and basically print backwards our XY coordinates. Now, what I want here is the 3D printer to hover over the print that is still stationary on the bed, and I don't want that Z axis to move. I don't want it to dispense any filament, and I don't want it to heat up or do anything like that. I just want the X and Y axis to move so I can go backwards in the code one line at a time and see the position. So this is going to do all of that for me. So this first command, head, is going to print out just the top of a file with a certain number of lines, and we will put those lines in as a variable, the second command line argument, and we'll also give it a file, the gcode file that we want. So we're going to print a certain number of lines from that gcode file. We'll take the output of this command and we're going to pipe it into grep, and we're going to search for this regular expression. And this regular expression is going to give us an x or a y followed by some number. And that is going to signify some number of, or some xy coordinate, some movement that it is supposed to make on that xy plane. Now we're going to send that output into sed, the stream editor, and we're going to do another regular expression. And this time we are going to filter out any E, F, or Z commands. This is our extrude, our filament speed, and our Z axis movements. And we want to filter all of those out. So we search for any E, F, and Z followed by a number, and we're going to replace that with nothing. That's what's between those two. And we're going to do this globally. So we're going to search for this regular expression, replace it with this globally. And finally, we're going to pass it into tac, which is just cat reversed, and that is going to reverse our file. So this is going to print the file backwards, only giving us the XY coordinates. Now from there, I want to be able to step through and basically send that command one at a time to the 3D printer so I can see where it moves. But I wanted to automate this a little bit, so this script down here just helps automate that. Basically, I'm going to take the output of this file and pipe it into this file. And it is going to, one line at a time, send that command to the device and then wait for me to press a key, and then it will send the next one. This time I'm not going to be using any pipes since I'm moving things so slowly here, manually hitting enter every time I want it to move. This is not going to really need to be so clean. So it's just going to kind of raw pipe it over to the device. I can test this though over here by running this command, which is basically going to call our reverse and search, which is this top one, on our G-code, giving the specified number of lines, which is basically where it crashed, or at least the last coordinate I can find. And then we're going to pipe that into our script down here, and we're going to, for our command line argument of the device we want to send this to, usually we would send this to the 3D printer, but here I'm just going to send it to standard out so I can see it printed on the screen. And as a matter of fact, I might want to send it to standard out no matter what, so we'll see. Anyway, so we can see here we print one at a time, each line of the code backwards. If I hold enter, I could print a lot of them. If I did that, I would probably want to use some pipes. But yeah, so this is going to help me walk backwards through the code to see where it actually makes sense for this to have stopped. Okay, so before stepping back through the G-code commands, I need to make sure that the XY coordinates are reset. So currently it thinks this is position 0, 0, so I need to give it its true 0, 0. And I need to be a bit careful how I do this because there is an object on the device. So what I want to do first is tell the Y position to move to 0. So I'm going to send that to the device, not to my output. Okay. Now we should be safe to send it G28, which will reset all axes. So next I'm going to want to set the Z-axis to be appropriate. So I think about 30 or so, 33, let's give it 35 just to be safe. Now I should be free to walk backwards through the commands. So here is the command that uses those scripts that I wrote to walk backwards through the G-code. Now, it's a bit difficult to see at the moment, but there is a blemish on the object that is currently being printed. Now, this came from the power outage. When that occurred, the hot end was left on the 3D print, and this ended up melting part of it. Now, I was able to smooth this out, so I don't think it will affect the final product in the end, but it does give us a nice target to see where we were when we left off. So as we step through these commands, we can kind of watch to see when it crosses over that. So this is going to basically bring us to where we left off. So that's where we were. And we can walk through one command at a time. And we're waiting to see if it will go over the blemish. So here we can see it's kind of printing that lattice structure that's in the very back. Oh, but here it seems to be potentially approaching the target. No, still building the lattice. Having watched this 3D print in action while it was working, I know that it goes through this whole lattice structure before arriving at the blemish. So at this point, I've gone through a large number of commands, and we have yet to arrive at the blemish. This indicates to me that we are going in the wrong direction. So I'm currently starting where the log ended and moving backwards, back to the beginning. And since I am not arriving at our blemish, it's just going over this lattice structure, that indicates to me one of two things are occurring. Either we are in a queue, in which case the log has absolutely no bearing on where we actually left off in the print, which is unfortunate, or the true point that we left off at is in the garbage that was in our log. So at the very end of the log, we have some corrupted data, and it seems it may be that we have to go further into the print rather than further back in the print, if that makes any sense. So what I'm going to do right now is actually cancel this, and I'm going to make a slight modification to my script so that it will go forward instead of backwards. Okay, so I've modified the script, so hopefully now we should be able to move forward in the G-code. So if I start sending commands, we'll now be able to move in the other direction, and we are again looking for exactly the same thing. We just want to see where it is when it actually moves over the blemish, and hopefully this one will be a lot sooner. Although it seems to be going through the lattice structure again, which is concerning. Oh, there we go. That was it. Okay, so we now know exactly the command that it sent that went here, and it was only a few commands after we actually crashed. So this should be actually a complete list of everything that happened. So what I want to do actually is restart this. So I'm going to send it our Y command again to bring it back to 0. And then we're going to reset the axes. We'll give it a better Z position. Whoops. And now finally, we're going to go back into our command, and I'm just going to pipe it into one more command. And I'm going to send it into T. So we are still going to be able to see the output in standard out right here on the screen, but I'll also be able to save it into a file. And what do I want to call this? Step.log. So this will give us a log of all of the commands that we step through so that I can reference them later and we don't have to go through this process again. So here we return to our starting point. There are a few actions. Looks like something to do with the lattice. And beforehand, I want to go kind of close in here and take a good look so I can see if it actually goes right over that blemish.
That looked correct to me. Going a little further just to be safe. It might have been that one. That second one looked like it was
In a little bit further, and it looks like the blemish was right on the edge. It was most likely one of those two, though, so we have our log. And so from here, we should be able to pick an appropriate place to restart the print. Okay, so after a sufficiently long time printing, we can see that the job succeeded. Well, it succeeded in resuming. Ultimately, the print failed. We had some problems around back. This was frankly just poorly designed on my part. That's a flimsy way to design that. And I ended up having to restart the print several times. You can see there's a line here from the first time, and then a second line here from the second. We had a third power outage, and I was not able to recover it from that. The body came loose from the print bed, and so ultimately the print was ruined after many, many hours of working on it. But we were able to successfully restart the print twice, which in the future will be really useful as I continue to do these prints. So unfortunately, this project was a bit of a failure in the end. This design really isn't that good, and the print failed in the end, but we learned quite a bit about how to do this, so I'm actually rather pleased with the progress, and I'm going to continue working on this and try to improve on the design. But for now, that will do it. So thank you for joining me. I hope you enjoyed, and I'll see you next time. Toodles.